So what we're going to look at now, can you see okay? Do you need to turn the light off?
Yeah.
Yeah, it's kind of hard. Okay. Alright. So what we're going to have a look at today is something called degree 2 systems. Yeah, so there we go. Degree 2 meaning that we are trying to find two unknowns.
Simultaneous.
It's the same thing, very good, yep. So degree 2 systems, what are they? These are just, simple way to explain it is two linear equations. For example, y equals minus 6x plus 8 and y equals minus 7x plus 9, and every time you want to find x and y, this is your goal, this is your job target, yes. Okay, so what we're really going to do is look at the different methods to find this. Now, in fact, everybody knows at least one method from middle school, but really what you're learning today is the different methods. So, if we think about the last class, what method could we use? Well, okay, firstly, I should say, what type of graph are these? What type of shape do they make? What type of picture is it? It's a straight line. But because there are two equations, you have two straight lines, yes. So the x and the y here represents where the two lines meet, the intersection point. That's what it is, okay? Ah, finally! What happened to you?
I'm no longer alone.
Well, yeah, that's what they said, but how come you weren't with them? You don't like them? I understand.
They walk too fast.
Oh, they walk too fast. Why did you walk so fast? Were you trying to get away from her? No? Yeah, you sit down, it's okay. And then I know that your timetable has changed a little bit, so from next week it shouldn't be any more changes. Like I said, I asked for the room to be changed because this room has a projector and the other room has no projector. Except for one, which will be in the building, the B building, but this one is for the tutorial. So I don't need a projector because we're doing problems on the board.
It's Monday.
I think it's Monday we'll make the tutorial. So if we think about the last class, what is one way from the last class of finding this point? What could we do? Remember the last class. What could we use in the last class to find x, y? Any ideas?
Midpoint. Midpoint.
No, midpoint, no. Because for midpoint we need 2 points anyways. Any ideas? Any ideas? So my question is, think about the last class. Is there something in the last class you could use to find x, y, to find where they meet?
The perpendicular intersection.
Yeah, but what did we do in the last classes?
Green.
Nope. Nope. You're thinking too difficult, too complicated. I'll tell you, yeah? Thank you. As you said, draw the picture. So you can make the graph of the two and then see where they meet. Okay? So what I'm going to do, this is our first method, the graphing method. So I'll just use my computer program to make a graph. Do you use this method in the exam?
No.
No. Why not, do you think?
No, take all that.
Well, it takes time, and it's not accurate. You know, you won't draw nice. It's difficult to draw nicely and accurately.
No.
Yeah?
Okay.
Yeah, but you might not meet the point easily if it was something like x
We
is
usually have one
1.2.
book or graph book separate.
Won't work. Won't work always. if x was something like 1.256,
We can
you would need to be a
make
machine to read the graph that accurately. Okay, so let's actually use these two as an example. Did you write these two down? Yeah. So let's draw them. So this is our first method by using the graph. Y equals minus 6x plus 8 and y equals minus 7x plus 9. So we shall graph. First one. Second one. Okay, I need to adjust slightly. No. Right, we're getting there. Okay, that's not too bad, I guess.
Yeah.
Mm-hmm. It'll have to do. So it looks like around about here where they meet.
Yeah.
So what is that point? 1, 2. Looks like it. Now it might not be. It might be 0.995 and 2.01. You can't know. But at least you know it should be about 1, 2. So that's the first method. So our first method is the graphical method. And really, it can be summarized as you said, draw the picture, use the graph. Which you actually never do. So I'm not going to talk any more about this. It's not the best way to do it. Let's go to the second method. So the second method, does anybody know any other methods to find the answer? So, yeah, you can read. They're in the book, I know. But what do you remember from high school? Substitution and?
Elimination.
Yes. And anything else on the page? I think which is most common in high school?
Substitution.
For you maybe, yeah. I know other people. Do you know the methods? Or you maybe don't know their names, that's okay. But we'll look at the next one, which is substitution. Okay, so substitution method. Right. So well, you know substitution method, so what's the key idea here then? Or do you know it?
Yeah, you substitute like y in the first question into y in the second question.
Yes, that's it. Can anybody give me another verb for substitute? Another verb that means substitute. Replace, yeah. So for example, if I have y equals 3x minus... Actually, you know what? Let's use the same one we did a moment ago. Y equals minus 6x plus 8 and y equals minus 7x plus 9. The substitution method means you take y here, y is equal to this, and you put it in here for y. So this means you get minus 7x plus 9 equals minus 6x plus 8, which is easy peasy. That x is 1. But how do I get the y?
Then put that value in the equation.
Yeah, we put the x value into here or here. So if I put x in here, I get y equals minus 7 plus 9. So what does y equal?
Minus
Positive 2. So the intersection point is 1, 2, which is what we thought it would be from the graph. So that's not so bad. Okay, so write this example now. So this is our second example, the substitution method.
If you substitute x from the first equation, will you get y as 1?
Yep, you will. And if you don't, you made a mistake. Okay. You got it? Yeah. So the next method, I think, is the most common method in high school.
That is
Elimination method. Method 3. Elimination method. So let's have a look at this method. You have something like 3x plus 4. And let's make it a bit more interesting. Okay. So the elimination method works like this. What you do is you look at the x's or you look at the y's, doesn't matter. I look at the x's and you try to make these the same by multiplying. So you say, okay, if I multiply this by 2 and multiply this by 3, this will become 6 and this will become 6. So let's do that. So we have 6x plus 8y equals 10, and 6x plus 15y equals 3. Because I multiply everything by 2 and I multiply everything by 3. Now what you can do next, you are allowed, no actually I'll wait for you to be ready because people get confused here. Okay. You can add or subtract. Right, no, so I want to make this point really clear. You can add or subtract, and the order you can swap. So for example, I can do top plus bottom, top minus bottom, or I could do bottom minus top, or of course bottom plus top. So you can add or subtract, top or bottom, the order is not important either, okay? So for this example, should I add or subtract if I want to cancel x? Subtract. And should I do top minus bottom or bottom minus top? No, there is a better one to pick here to make my life easier. Bottom minus top, because I can do 6x minus 6x, gone. 15y minus 8y, 7y, isn't it? 3 minus 10, minus 7. So I have 7y equals minus 7. So, y equals minus 1. Let's write that down. So I'll do here, if I call this one A and this one B, I'll do B minus A. These are gone. That's 7y equals minus 7. So therefore y equals minus 1. And just like in the last method, we can find the x by replacing. So if I put the y in here, I get 6x minus 8 equals 10. So I get 6x equals 18. So this means x equals 3. So the answer,
Was it in anyone, teacher?
yep, anyone. In fact, actually, yeah, not only can you put in anyone, you can put in any of the four. So you could actually put it here, 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 or here.
Okay. 4 of them.
Any of the four, yep. Okay, write this down. Is this the way you learned in high school?
The bottom.
Yeah, but I mean, which was more common? Substitution or elimination? Both? Okay. What about for you? Which did you do in high school? Usually elimination, yeah? And then how's it in Korea? Elimination or substitution? Elimination mostly? Yeah, and what about you guys? Both equally, yeah? And you, Tahar? Both equally, okay. It doesn't matter which way. It doesn't matter. But please remember, sometimes in the exam, they'll actually tell you which way to use it. So the question might say, use substitution or use elimination. Now, most of the time, they don't say this. So most of the time, you can use any method. But a very, very small amount of the time, maybe 5% of the time, they'll say, use this method. So just remember that for the exam, okay? You know, if they say use elimination and you do substitution, you get 0 marks. So just be careful about that. Okay. I'm going to look at another method. There's actually one more method which I don't think people have seen before. Can I scroll down? Yeah. Not French this time, sorry. Gaussian. Now, before I start this method, I should say this method is not on the exam. The reason I'm showing you this method is because it is a very useful method. And it is a very useful method for very difficult and very big problems. This method we are using is for 2 variables, x and y. But this method works very well for 3 or 4 variables. In fact, in physics, which is what you're all doing, when we study electricity, we will have problems that have many variables in it, like W, X, Y, Z. And I find this method is the best for when you have many, many variables. So this is why I'm showing it to you. So it is most important for physics students, which you all are, okay? So let's see how this method works. Let's have a look. We have something like this. Two over 7x minus 3 over 5y equals minus 5 over 9. And 2 over 9x minus a half y equals 5 over 7. Okay, you got that? So what we do first is we write this in a block. Two over 7 minus 3 over 5 minus 5 over 9, 2 over 9 minus a half and 5 over 7. this makes it easier to write, and you read it the same way. This is, no, it's not. You read it the same way. This is 2 over 7x minus 3 over 5y equals minus 5 over 9. 2 over 9x minus a half y equals 5 over 7. So let me just scroll down a bit to make space. So all I'm doing first is to put it in a box. Yep. Now, the first thing you do, you ask, do I have x here, and do I have a y here? Do I have an x here? I do. Here it is here. Do I have a y here? I do. So we're good to start. What do you do if you don't have an x and a y? So what I mean by that is, for example, let's say I get rid of this. Let's say this was 0x, for example. There's no x here. So what I could do is I could just swap them. Then there's an x on the top and a y on the bottom. I mean, it makes sense, doesn't it? You can swap these. There's no problem to swap them.
Yeah.
So if there's no x at the top, move them around until there's an x and then there's a y. And if you have a z, then it's x and a y and a z. Okay. So let's go. Yeah, x, y, z. Keep it like this.
How do you move it?
You just swap the lines. Like, literally take the second line, move it to the top, and take the first line and move it to the bottom. A straight swap.
Yeah.
Yeah? So do we have an x in the first line? We do. And do we have a y in the second line? We do. Okay. So it's a little bit like elimination. You know, it's called Gaussian elimination. And what you try to do, well, what we do first is I'll multiply this one here by 7 over 2, and then I'll multiply this one here with minus 9 over 2. And the reason for that, your first job for this problem is to make both of these the same. Okay. Let's see. So this becomes 1. Yep. This one here becomes minus 21 over 10. This one here becomes minus 35 over 18. Is that right? Yep. This one here becomes minus 1. This one here becomes 9 over 4. And this one here becomes minus 45 over 14.
But you said we need to make the same.
Sorry, I meant to say the same and an opposite sign. So, like a 1 and a minus 1, or a 2 and a minus 2.
In x 2 over 7 is positive.
In x2,
Over 7.
I only care about making the x's the same.
No. I mean, you said we need to change the signs too. For both of x's.
No, just the second one.
Just a second.
Yeah, one needs to be positive, one needs to be negative. Yes?
Second one you multiply by minus 9.
Yeah, minus 9 over 2, yeah.
Why minus? There's no minus here and 2 over 9.
2 over 9? 9 over 2.
Sorry, this one.
This here?
Yes, this
There is a minus. Sorry.
Yes, there's minus, but here there's no minus on 2 over 9. Right? It has changed to 1.
Oh yeah, so if I multiply 2 over 9 by minus 9 over 2, it makes minus 1. If you multiply those.
You want it to minus 1?
I do, yeah. So just to be clear, what I want here is a positive, a negative,
Okay.
but the same value. So I have a 1 and a minus 1.
Okay.
If you want to have the negative sign of,
Yes, it is. That's fine. Yep, that's fine. Yeah.
Okay.
so the minus 9 you can put into either in minus 7.
Oh yes, yeah, you could put the minus up, like minus 7 over 2.
Alright.
Yeah. Hey, focus now. Focus. Okay, do we have this written down?
Yeah.
So there's 2 rules here. You can multiply any row by any number except 0. So for example, here I multiply the first row by 7 over 2, and I multiply the second row by minus 9 over 2. So my first rule is I can multiply any row by any number except 0, because if I do 0 I get 0, 0, 0. Okay? And my second rule, there's only 2 rules, my second rule is I can take any row and add it to any other row. So for example here, I will take the first row and add it into the second row. So what's 1 and minus 1? 0.
Okay, that's fine, right.
Well, you can, but I'm trying to keep it simple, so that's why I made the minus here. So 1 and minus 1 is 0. And then we add those 2 together as well. Okay? So you can add any rows together, and you can put the answer on any of the 2 rows. So what I'll do is I'll add them together and put the answer on the second row. So let's see what happens. You need your calculator maybe here. So 1 and minus 1, 0. Calculator please, minus 21 over 10 and 9 over 4. What's that going to be? It's going to be quite large.
Minus what?
This one and this one. Add the 2 together, please, like I said 3 or 4 times now. So minus 21 over 10 and 9 over 4.
3 over 20.
3 over 20? Yeah. And then the last 2, minus 35 over 18. And
minus 2 or 20?
well, he typed it in his calculator and trusted him. Maybe this is my first mistake.
There's 1 minus 10.
Yeah, but that is maybe smaller than 9 over 4. It is smaller than 9 over 4. Because 9 over 4 is 2.25. And minus 21 over 10 is minus 2.1.
So the next one,
Yep.
add again.
Yep. What's the next one?
Minus 335.
Minus 325 over 63. Minus 325 over 63. And then we keep the first row the same. 1 minus 21 over 10 minus 35 over 18. So that stays the same. So now we're actually finished, practically. Because if you think about what you have here now, if I write these equations back, I have x minus 21 over 10y equals minus 35 over 18. And here I have 3 over 20x equals minus, y equals minus 325 over 63. So look what's happened. Can you get y from this equation now?
Yes, definitely.
Yeah, just type it in on the calculator. Here. So this gives me y. And then once I have y, I put it in here, and I can easily get x. So the goal in this method is really to make a 0 here. Now you don't need to write these 2 lines down because you can actually continue even more. I mean, if you want to write them down, that's fine, but I'm going to go back to my block. So calculators please. I'm going to multiply this one by 20 over 3, and this one here by 10, no, I want to make my signs the same, so if I want to keep this negative, it'll be 10 over 21, and this one here will be positive, okay. So this one here will be 10 over 21 minus 1. Tell me what you got here, please. And then here it will be 0, 1. So what's this number? And what's this number?
Minus 25 or 27.
For the top one?
Yes.
Yeah, and then for the bottom one? Are you sure about that? Okay, and then for the bottom one?
Minus 5,500 over 189.
Like this?
Yes.
Okay. Now, we should add rows together. Which well, we only have 2 rows, so we add the 2 rows together. But where should we put the answer? Should we put the answer in the first row or the second row? What do you think? First row. You must keep the 0 here. The 0 is what makes you happy. So we don't put the answer in the second row, we put the answer in the first row. So let's do that. So 0 plus this is the same. 1 and minus 1, 0. I keep this one the same. So this one's going into there. And earlier, what did I do? I put this one into this one. So now I'm putting it that way around. So this is the same. So can you take out your calculator and add these 2 together? These 2 together, we'll put the answer here.
Minus 2225.
Yeah. Minus 2225 over 63. Only one step left to make this really nice. Now I know it seems like a lot of work, but when you start doing problems with 3 and 4 in it, it actually is the quickest way to do them. So I'm not showing you this so that you can use it for X and Y. I'm really showing this method to you so you can do it for X, Y, and Z. What should I do next? Any ideas?
That's X.
I'm going to multiply this one by 21 over 10, and then I'm finished.
Why did you multiply it by 2 times?
You'll see. All will become clear.
Or these 2 steps?
No. Watch the magic. Magic's going to happen now. I don't want you to miss it. Okay, so can you just multiply these 2 together? Tell me what you get. Yeah.
Oh, I get it.
You see the magic that's happening. What number do I get here?
Minus 445 over 6.
Like this?
I just need to...
Now this here makes you very happy,
Yeah.
because this is 1x plus no y, so this is x equals minus 445 over 6, 0x plus 1y, so y equals minus 6500 over 189.
Can you go on?
Yeah. Which is correct. And you see what happens? You basically have taken your problem and you keep working with it until you've made the problem so simple that it's actually the answer. So the goal here, if for example you have 3 x, y, z, 1, 2, 3, 1, 2, 3, 1, 2, 3 equals number, number, number. What you're trying to do first, is to make this. So when we have, that's like this step here, this is like step, or the first half, is to get zeros in the corner. So if you have a square, you want to make this, and you have this bigger square, you want to make 3 zeros here. So you have 2,
3 zeros. Why?
yeah, 3 zeros. Because look,
Okay.
if these are x, y, z, how many x's are here? No. How many y's are here? No. So you have some z equals some number. So can you get z from this one?
Yes.
Yes. Then if you have z, what 2 are in this line?
The X and Y and Z.
And if you have z, what can this give you?
Put the Z.
And you can get y. If you have y and z, what's in this one?
You can find X.
You can find that. So first you try to make a triangle, and then, if you want to, you can continue and try to make this shape. 1, 0, 0, 0, 1, 0, 0, 0, 1.
Wow.
And then you can see that these 3 numbers here, what are these 3 numbers?
The answer.
The answers, x, y, and z. So to finish, I'll do one example with x, y, and z. You know you'll like it, I promise you.
Excuse me.
Yeah.
Do we always can make the last square has 2 zeros?
It's always possible.
It's always possible.
It's always possible, yeah. Yeah. And I'll show you an example.
Okay.
If we have 3 x, y, z,
Yeah.
then we'll switch and so the next time we'll go down.
What do you mean?
Like over there,
Yeah.
first we add to both
Yeah.
equations,
Yeah.
but we write it in the lower.
Or you can still write it anywhere. Yeah. Well, I need it too, I mean. Here, I'll show you, I'll do an example. Can I go down?
Yes.
Yeah. Okay.
Something.
Yes.
If we have 3 equations, we have to multiply, add 2 times.
No. You'll see an example now. Let's have an example. So let's say we have something like x plus y plus z equals 3. 3x plus 2y plus z equals 6. And then, let's say, well, let me make it a little bit more difficult. 3x plus 2y plus 3z equals 8. And then let's say here 2x plus 3y plus 4, oh, let's put a minus in. Minus 4z is 1.
Wow.
This is 2x.
Yep. Now the reason I'm giving so much time to this method is because everybody has seen the other methods before. This is new, and I think you'll benefit from seeing 2 examples of it. Okay, you ready to try this? So first we make our block. 1, 1, 1, 3, 2, 3, 2, 3, minus 4. 3, 8, 1. It's like it, but it's not quite the same thing. Okay, so I will do, multiply,
We can
Multiple-
make any of these the same.
what do you mean?
Like X all the same, Y all the same, Z all the same.
No, there has to be an order to it. Watch carefully. First step, do I have an X here?
Yeah.
Yeah, do I have a Y? And is that, yep, so we're good to start. Okay, so I'll multiply this one by 3, minus 1, oh sorry, not 3, need to make a 6, sorry. 6, minus 2, and minus 3. So if I do that, I'll get 6, 6, 6, 18, minus 6, minus 4, minus 6, minus 16, yep, minus 6, minus 9, 12, minus 3.
Okay.
Now, what I do is I add. So I'll add the first row and the second row, and where will I put the answer?
So,
In the second row. So what I'll do is, I'll do the row 1 plus the row 2, and I'll put the answer onto row 2. And I'll do this one as well, row 1 plus row 3.
and put the answer in row 3.
Yes, I'll put the answer on row 3. Okay, so which row is the only row that I'm keeping the same?
Row 1.
Row 1 is the only one that's not getting something new. 6, 6, 6, 18. Okay, row 1 plus row 2, answer goes on to row 2. 6 and minus 6?
0.
0. 6 and minus 4? 2. 6 and minus 6?
0.
0. 18 and minus 16? 2. Now what do I do next? Row 1 and row 3. Answer onto row 3. 6 and minus 6? 0. 6 and minus 9? Minus 3. 6 and 12? 18. 18 and minus 3? 15, isn't it? Yeah. Look, I almost have my zeros. I have 2 of them here. What do I need to make 0 now? What's the one? There's one left I need to make 0. This one here I want to make 0. Yep. So let's do some more multiplying. Keep this the same. This one multiplied by 3, and this one here multiplied by 2. So I have 6, 6, 6, 18, 0, 6, 0, 6, 0, minus 6, what's next? 36, 30. Okay, what rows do I add together and where do I put the answer?
Row,
And remember, I want to make this 0.
row 1 and row 2, or
No?
2 and 3.
Row 2 and row 3. And which one do I put the answer on?
Row 3.
Row 3. Let's see what happens.
You're only adding one row.
Yeah. 6, 6, 6, 18. 0, 6, 0, 6. Okay. 0 and 0? 0. 6 and minus 6? 0. 0 and 36? 36. And 6 and 36? Sorry, 6 and 36. Okay. Multiply by 1 over 6, multiply by 1 over 6, multiply by 1 over 6. Make our life easier. 1, 1, 1, 3. 0, 1, 0, 1. 0, 0, actually I could have done 36 in the last one. 1, 1. That's 36.
Oh. So that was one. Okay. What's next to?
Now, what the last thing I would like to do, I would really like to make, hang on, where's my pen gone? 1/36. My pen, come on. My laptop's a bit frozen. You see that on the top line I have 1, 1, 1.
Yeah.
What would I like on the top line?
1, 0,
1, 0, 0. So what I'll do is I'll multiply the second and the third line by -1. Where's my pen gone? Come on. Ah, here we go. -1, -1. So this becomes minus, 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 minus. And now I'll do row 1 plus row 2, and where will I put the answer?
the first one.
Row 1. 1, 0, 1. We're a bit stuck. 1, 0, 1. What's here? What goes here? 2. Okay. And then everything else is the same. Okay, and then what should I do now? I should do row 1.
Plus row 3.
Very good. On to
Row 1.
row 1. 1, 0, 0, 1. 2 and -1. 0, -1, 0, -1, 0, 0, -1, -1. So to finish, multiply by -1, multiply by -1, keep this one the same. So now I have 1, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1. So what's X?
1.
Y
1.
and Z 1.
And is 1.
Yeah.
1 plus 1 plus 1 plus 3.
Now, this method, it might seem like it takes a long time to do, but the reason it takes so long to do is because I'm speaking as I'm doing it. But you can imagine that if you just, like a Sudoku puzzle or something, if you just have some paper, you can, work it out pretty quick. It's only taken me a long time because I need to explain each step. But if you think about it like a puzzle, there's 2 steps you can do. You can multiply, or you can add rows together. And it's like a game. You're trying to get zeros in the corner, and then once you get those zeros, you can put the lines together to make 1, 1, 1. And then you're finished, because now I know X is 1, Y is 1, and Z is 1 here. Yeah? I don't know if you like this or not. You have that look, like, when I was Stephen, why did you show me this? Well, I know you've never seen it before, right? Yeah. Trust me, it's a good method. You should learn to like it. Okay.
So tell me that.
It's not in the math exam and it's not in the physics exam, but it's a method I find very useful for some of the physics problems.
Confusing.
Yeah, which we'll do in the next chapter. Yep. Yep.
Next one.
No, not next week. We're still doing mechanics, but we'll go on to electricity. Okay, what else?
Will tell me next time. Maybe I.
No, don't come in the exam. But it's a method you could use in the exam. for some problems. You don't have to use it. Remember, we have how many methods? Graph, substitution, elimination, and Gaussian. There's 4 methods. We never use the first method. You can use the 3 other methods. In the exam, they may ask you for substitution or elimination. So you must know these. The last one is optional, but it's a good method, especially for physics problems, when you have many variables, like x, y, z. But for some of the physics problems, you can have like 4 variables, w, x, y, z. So it's good if you have some method that works well for any number of variables.
So in physics, probably can I use another way or only?
Yes? No, you can use another way. I'm just giving you some advice. Okay. I tell you what, we have a double class, don't we?
Yeah.
So I think you need a break after seeing that. So we'll take a break for a few minutes and then we'll start the next topic. You look like you need coffee or something, yeah? We'll take about 5 minutes, maximum 10. I'm going to be starting the next topic in 10 minutes exactly, okay? So take 5 to 10 minutes.